We will wait a couple minutes and then we'll start. All right, let's go. I will share my screen. No, stop video. Share screen. Desktop 1. So, can you see me? Or to be more precise, can you see my screen?
Yep, we can see.
Yes, we see.
Cool. Okay, so first of all, we should finish up the last lecture that Ilya didn't have time to finish, and today he is a little bit late due to his work obligations. So last time we told you that today we will have a kind of practical lecture based on a set of small exercises that we called katas. Here is link to the GitHub, and we will get back to it later. But before that, some theory. First of all, quality of collections. One more thing that is very cool about Clojure is how practical the quality is. If you're familiar with the most prominent language on the JVM, the Java itself, you might know how hard sometimes equality operations are, especially for collections. And in Clojure, most of the obvious problems, not obvious, but most of the common problems are already solved under the hood. And the API that we work with gives us very concise and straightforward solutions. So, for example, we can test collections using the equals sign, as you can see on the screen, based on their content. For example, here on the first line, we use the built-in function range that provides, that generates a sequence from 0 to the required number, in this case 3. So range function generates numbers 0, 1, 2. On the next line, we test for equality the same range and manually hard-coded vector of the same symbols. And again, as you can see, the equality works, even though range function produces a sequence, an abstraction. We don't even know what the real implementation of this sequence is. And for the curious, there might not even be a real one, a real collection under the hood. It's just a lazy sequence that provides a new number as soon as it's requested. So when the range function is finished, there are no numbers at all. And on the other hand, the vector that we have hard-coded here is the real data structure that is stored in memory. But the end result is the same. They're both collections. They have, in the end, the same structure and the same elements, the same order. So the equality operation returns true. On the next line, you can see the same for a vector or a list. And once again, a small reminder that lists need to be quoted because the interpreter tries to evaluate them. And when we want to produce the data structure itself, it should be quoted so that interpreter does not evaluate it. And some counterexamples. The two vectors on the next line are not equal because they have the same elements but in different order. And on the last line, even though the first two elements are the same and in the same order, but the overall structure of the vectors is not the same. So they are obviously not equal. Okay. One more thing is conversion from one data structure to another. For example, given a vector of numbers, we would like to get only the unique elements. And the most obvious choice for this would be a set, because set by definition is a collection of unique elements. So we would like to convert a vector to a set. Or another one, we would like to get a map from a list of vectors, because map essentially is a collection of pairs, each pair representing a key and a value. And again, Clojure provides very simple and very straightforward ways for conversion. For example, on the first line, you can see how we can convert a vector to a set. A set is denoted by a hashtag and then curly braces. And as you can see, even though vector guarantees its order, it's by definition an ordered sequence of elements, the set does not. guarantee any order. So when we get back from the interpreter, from the REPL, we see that the order has changed. We can do the same in a different way. From set, we can get a vector using function vec. On the next slide, we can see how from a map we can get a vector of vectors. So again, a map data structure consists of key values pairs. Each pair has a key and a value. So it's kind of obvious that we can represent this sequence of this collection of key value pairs as a collection of tuples. Tuple is a small collection of 12 elements. And another way to generate a map is to call hash map function. And hash map function creates but in its raw form, the hash map function expects a variable list of arguments. And so if you want to push some concrete data structure into it, not elements itself, but a data structure containing the elements, we would have to use the apply function. And we talked about it a couple lectures back. Maybe we will see it again today. I'm not sure. Okay. Next. Namespaces. So another common problem in software design is that we need to break stuff up because creating our application in a single file is not, well, it's obviously possible, but it's not really efficient and not really easy to think about. So the natural solution for this is to break our program into different parts, put it in different files, name them differently, and then only call the stuff that we need from one file to another. And as any other language, Clojure has support for this kind of problem. And the solution is namespaces. We will not get into details of how they work under the hood, but simply put, namespace is kind of how you name your file, name your module, not the file itself, but the module that the file represents. And usually it is placed as the first line in your source code file. It's represented by ns macro, and then as a symbol, the name for the desired namespace. So when we create namespace, the next thing that we want to do is use stuff from other namespaces, call it or export it. And there are multiple ways how we can do enclosure, but we will for now use the require keyword. So in these two examples, you can see that we would like to import in our imaginary program the closure string namespace. And here we can do it using the keyword require and the vector of desired namespaces. And after that, we would have to use the fully qualified name of the desired function. In this case, closure string / split. First, we use namespace / name the function. And to a little bit simplify things, we can give aliases to the imported namespaces. And in the second example, you can see that we mark the namespace closure string as str. And then when we call this function, we can simply use str / split. Cool. Now, there is one more hack. This first example is the same as on the previous slide. But the second example demonstrates how can we bring all the functions from the imported namespace into our namespace using refer all keywords. In this case, you can see that we don't need to specify the namespace at all when we call this function. Generally, this is a bad idea. Generally, we should give namespaces to imported aliases, because without it, we might run into the problem of shadowing things. For example, the default namespace that is always loaded is closure core, and it has functions replace and reverse that are supposed to work with any sequence, generic functions. But closure string namespace also has functions replace and reverse, which are designed to work specifically with strings. So by referring all from closure string, we can run into problems. But sometimes this option is useful. For example, when we work with testing, particular closure test namespace. Okay, so testing. You might have heard about unit testing in general. Very popular framework in Java is JUnit, for example. And the idea is that as we write our production code, our business logic, we can, in parallel, write some other code to test the first code, to make sure that the first code is working correctly. And this technique is useful, first of all, because it gives us an easy way to run our production code and to see whether we whether we designed stuff correctly. And another positive result from tests, and maybe even more important, is that in large-scale systems, we often we unintentionally break stuff that we didn't even think about. So if our project has lots of tests and we run them on the regular basis, then we can see that while we were solving our current problem, we have broken another part of our software, and we can fix it. We don't have to wait for users to call us and scream at us. Okay, so as an example, on the left you can see a simple production code, so to speak. A simple file that defines its namespace and function square. And on the right, you can see a corresponding testing file that has its own namespace, which is usually is the same as namespace of the target file plus test. It imports everything from our target namespace and everything from closure test. And then it have written, you can see written, there are some, and then you can see a few examples how we can test the square function. We provide some inputs and we assert that the result is what we expect. Yeah, okay. This is the last slide, so let's quickly go through it. Here is an example of a few built-in functions that you might find useful. First one is interleave that mixes two collections into one in such way that the first element of the first collection, it takes the first element of the first collection, the first element of the second collection, the second element of the first, second of the second, etc., etc., etc. It's kind of like a zip line on our hoodies and on our codes. Interpose, as you can see, adds an element between every element of some collection. And by the way, as always in Clojure, we don't modify the existing collections. Collections that we get as a result are new collections, and the old ones stay the same. Those functions do not modify them. Next, group by is an interesting function. It returns a map. It takes as an input some function and a collection. It applies the function to every element of the collection and returns a map such that as a key has one of the possible results of the provided function and every element that returns this result. So here you can see that we passed the function group by an anonymous function that tests if some number is less than 3. Obviously, there are two possible answers, true or false. And so in the resulting map, there are two keys, true and false. And each key has as its corresponding value all the numbers that are either less than 3 or bigger than 3. Um, partition by. I'm trying to understand what they do just by looking at it, because obviously I don't remember from hand. Okay, I know what we will do. But first, flatten. Flatten is very old and very important and very useful function. As you might remember, we have extensively talked about the classic three: filter, map, and reduce. And there is this fourth brethren to them that is less widely used, but it's still as iconic as those three. And flatten takes a collection of collections and returns a single collection. It literally flattens it. So we take all the elements of the first collection and then all elements of the second collections, etc., etc., etc. Why flatten? Because you might imagine that this original vector of vectors is two-dimensional, and the resulting function is one-dimensional or single-dimensional or unidimensional, in the best part. Okay, any questions at this point? Feels like no. So let's get back to partition by. And this is a good point to demonstrate how this stuff actually works. When we meet some function that we don't particularly remember and can't understand what it does, we can go to the cloudredox.org site, which is community-driven documentation. Partition by. And try to search for this function. And read the documentation. And sometimes documentation tells us something magical, stateful transducer. We will not talk about transducers in this course. And trust me, you don't need it at this point. It's basically a function that returns another function that does some stuff to make stuff more universal. Okay, so looking at the definition, at the examples, we can see that partition applies the provided function and creates a new list as soon as the result changes. For example, given the identity function, and identity function is another one extremely old and fundamental, which simply returns the input. So identity of x is x, so to speak. You might wonder why we would need such simple function, but it's useful when we need to provide some simple function as a parameter, like in this example. Yeah. Okay, let's not sit too long on this. Okay, so it's time to get back to the kata. Here on the slide is the link to the project that we would like to work with. It's on GitHub and Ilya's account, and it's called Closure Kata. I guess just in case we don't have the slides, I will try to. Where's the chat?
It is in Ortos, just in case.
Ah, okay. Okay. So it's a project with some files, cool stuff. What should we do with it? Given that we work with GitHub, first we need to clone it. I will use simply the terminal, but I guess other ways. The project is public, so I guess you will not need to authorize in any way. Just clone it from GitHub. Cool. Now that we have cloned it, we can try and open it in IDEA. Sorry, it's a little bit hung up. Please. Something went wrong. Oh, Jesus. Did it help? Yep. I'm not. No, you didn't help. Yeah, is that cool? is done. Okay, it's done. So, given that we have downloaded the sources, what can we do now? In IDEA, either in here in the welcome screen, we can use open, or similarly, if you have another project open, you can use file, open, navigate to the directory with the project and simply open it. Okay, we will see here, you will see here some files, but the project itself is not configured. First of all, IDEA suggests us to add source root. Let's agree and add the SDK to the project. You should already have one, and we just choose it as it is. Cool. So now we have opened the project and we have added Java to it, the runtime, by adding the SDK. But you can see that everything is yellow and nothing can be resolved. And to deal with this, we need to go to project structure and libraries. And here we should add closure that I don't have. I have it on another computer. That's fine. That explains a lot. Oh, no, I was wrong. Not libraries, but modules. Modules, add closure. This will force DIA to download closure libraries and add them to the project. It will do its magic, index stuff, configure the project, and voila. Now everything is resolved and we can see all the definitions. So the simplest way after that to run it is to select the file and click run. And we will get some result. We'll see fail, but fail is exactly expected because we are using closure tests. And here we see preparation for exercise in which the tests don't yet work, and our task is to make them work. Okay. So again, open the project in the IDEA, add the SDK, it will suggest it to you, and then add the closure module in the project settings tab or window. Now then run by using right click and run. Why is it gray? That's weird. anyway. So let's look at the project at hand.
Sorry, can I ask?
Yeah, sure.
Do we have to add source root or test root?
Source root in this case.
Yeah,
To simplify things, we don't have separate source and tests in this project. Everything is under sources. Okay. So the project consists of a set of exercises. Each one has its own namespace and uses closure test and closure data. Another closure data in this file. We'll get back to it right now. Then from the closure test, we use the test definitions. Test definitions require some name, not name, but description, simply the string, and then some tests. In this case, we will write our production code just here using the let form that we have spoken before, that we have talked about before. As a reminder, let lets us create local names. For example, here we define a name customers and bind it to some value, and we create a name reach customers, and again bind it to some value. In this case, simply to the customers themselves, and then we execute the test functions. Is a function from closure test. It's a simple assertion, and the sole purpose of is to print out the pretty result when things go wrong, so that we can find where we need to look next. And then the assertion itself. Okay, to the practical part. We have a namespace called Kata data that basically defines a sort of database for us. We will work in the context of a big shopping center that has customers, has shops, and the shops have products have prices, etc., etc. And we will query this data set, manipulate it, and get answers to some questions. Generally, all our database is stored in a single name, in this case mol, and mol is a map containing of two elements. First one is shops, and the second one is customers. Here it is. So our mall or shopping center is a key of two elements. And each element has as its value a vector. First is obviously a collection of shops, and the second is a collection of customers. So each element is in this vector is a shop itself. Is a shop, and it itself is a map. A map with keys, names, and items. As you can see, the same structure repeats over and over and over because we have many shops. And each shop has a name, and each shop has a collection of items. And again, in the similar pattern, items is a vector of elements, and each element is a map. Map with keyword value, keyword value. So it represents the name of the product that you want to sell, and that not we, but the shop sells, and the price of this item. This is the direct example of the things that Ilya was talking on the previous lecture. That in Clojure, it's very easy to represent data using simple built-in data structures. We don't need to define some specific classes and then instantiate objects with particular values. We simply create maps to name things, to name sets of things, and we join them in vectors to show that they're the same. They're a collection of similar things. So these maps of shops we join into a vector. And by join, I mean we simply put it. It's not some specific action. Okay. So shops have names and items, and customers have names, ages, budgets, and lists of things they want to buy. In a similar fashion as shops. Okay, so that's our database, our source data. Now to the point of our exercise. Given this database, we want to find some stuff. So here we can see the formulation, so to speak, of the task. First of all, we want to find rich customers. And rich customers in this context are defined that as those who have budget over 10,000. Should have been 9,000. Would be funnier. Let's look at the data first. Again, our database consists of a map. In this map, there are data about customers, and each customer has his budget or her budget, their budget as a keyword. So what can we do about it? And as an example, so logically, the first thing that we want to get is from our database, general database. We will need to get only the customers. And in Clojure, as we have again talked about last time, we can use keywords as functions. Under the hood, they implement the IFN interface and all that jazz. But practically speaking, we can use a keyword as a function and give it as a parameter some map, and it's supposed to return, it will return to us the value under this keyword or nil if there is nothing. So to make things clear, we will additionally add the REPL to the project, the local REPL. Okay, slower. We can add a run configuration to IDEA in this menu. Here we should find from the template closure REPL. Choose the local REPL. Give it some name. And I think all of the stuff should be by default. Okay, recommended, we will choose command. Okay, simply added the run configuration from template. That's it. Let's run it. Ten. Well, ready? Yeah, it's ready. Sorry. So, okay, now that it's the REPL is running, we can load the file, the current file into the REPL. I have pressed Alt-Shift-L, and you can see the same in here, and the tools to REPL as load file in REPL. Another one that is grayed out because cursor in wrong position, but send form to REPL. Alt-Shift-P. So can stand. I guess this was work. No, it won't. Yeah, I just select the desired part. In this case, simply the name mol, and I press Alt-Shift-P, and it goes into the REPL, and we see the result, the full map as it is. Okay, cool. Now, from the whole map, we will get only the customers. Same, I select what I want to see, I press Alt-Shift-P, and I see that now, as a result, I get not the whole map, but only the value under the keyword customer. Okay, cool. So, what's next? Now, from this list of customers, we need to get only those that have budget over 10,000. And naturally, this sounds like a filtering function. So we will filter something from something. We will filter from our customers. I will just put it here for now. The filter function expects some expects a predicate that tests each element of the collection. And in this case, we will use how do I put it? Well, let's start from the beginning. We need to test whether the budget is bigger than 10,000. Let's, for starters, do it like this. We need to find a budget somehow. For now, it will be just question marks as a template placeholder. And put the outermost function first. Meaning that we need to test that something is bigger than 10,000. Okay, so when we're filtering a list of customers inside this function, we are working with the customer directly. Well, here is an example of a customer, and the customer again is a map with the keyword budget, and is in the same way that we have took all the customers from our shopping center database, we can get the budget from every customer. So let's do it. We will write another function and again use the budget keyword. And here we have used the mall name that is defined in the another file database. And what we can use here, we are, again, the predicate will, to the predicate, the filter function will pass an element. So we will be dealing with customer, but how can we reference it? Reference it as a parameter to anonymous function in this way. Again, we have talked about this before. So let's test it. For now, about this way. No, again. Okay, you can't see the customer's name inside of that. Well, magic doesn't always work. But if we send the top form to the REPL, and in this case, the top form is the testing itself, we will see the result true, meaning that our test is successful. For example, when we do the same for the next test, it says false, and it shows us that something went wrong. There were failures. But in the first example, after we have implemented this code, we can see that the result is true. There are no failures, and that's it. So our tests consist that our tests assert that the number of reached customers is 2, and it's correct. And then it checks their names. And again, please note that it works the same way. We take all our reached customers and we transform a collection of customers into a collection of their names using the name keyword as a function. And then we put them all into a set because we don't want to care about order things. Okay, that's the point of the exercise. And we have spent an hour to introduce you to it. And now you can start working and ask questions. Guess the first question will be from me. Have everyone succeeded into setting up the project? Well, logically, you might have been listening to me, but if you haven't already, now is the time to try and set up the project. If you have some questions, please. Okay, here we are.
I have a question. Could you please repeat one more time with this tools REPL, how it works?
So when the project was first opened and configured, I did not have this option, the REPL option. So I went here in this menu, the edit configurations. Here, using the plus from the template, I selected local closure REPL and simply gave it a name. After that, I just pressed the red run button, or the green run button to start it. And then this window opened itself. It might close, but usually it's attached to the right corner, down right corner. So if you don't see it, try to. Does it work?
Yeah, it all works for me, but I don't understand how to show information in this REPL, how to find it, because when I click this like tools, REPL, it doesn't work for me, I guess.
Tools. You mean this?
Yeah.
Okay, so we have a couple of options here. First of all, I am currently looking at some file with a namespace and all that. I can send the whole file into the REPL, meaning it basically takes all the text sorry, it takes the whole text content of the file and puts it into the closure interpreter inside the REPL, and we see the result. Along the way, it loads all the required namespaces so that we can use it later. Does this work for you? Open a file and press Alt-Shift-L.
I have a
Well,
question. If it passes, then we don't see anything, right?
If it passes, you should see true as a result. Another way to run it, okay. REPL is useful, but not required tool. Another simpler way to run this stuff is to navigate to the tree of files and then use run here. The right mouse button and run. It will run the file directly, and it will give the same results with failures in this case. Try this.
so we use REPL just instead of this run.
Those are two ways to.
Okay.
The REPL will kind of give you an opportunity to experiment, to
yes, exactly.
write small pieces of code which you will be able to test at once. Like you will be able to run them, and the REPL will give you the responses, so you can test out the ideas how you like want to write your program. And just simply running the file, you can edit the file inside. You can write some new like things inside the file and then rerun the file each time. Generally, it will also work, but like REPL is a bit more convenient because you can run a single command at a time.
Okay, so to run, for example, as you said, a single command, do I have to choose this, a single line, or what?
You go to REPL and Nikita, write something in REPL. you go to REPL and you just write a new command here, like here, yeah.
Yeah.
And the REPL will execute it.
Yes.
And if it works, then you can now take this command. Yeah, you can kind of like play with this command until it does what you want. And once it works, you can just copy paste it into your file, into the place where you want it to work.
Okay, so I can do this like testing in this small window on the right.
Yep.
Okay, but what if it's written like I have only opportunity to read only? I can just click it here and write something. So I have like this REPL and closure, but I can write it.
Maybe you can share your screen and we will take a look. It's hard to understand.
Okay, 1 second.
Also, is there a difference between Java versions needed for closure?
After the 8, no. 8 or higher.
Okay.
Generally 8 or 11. Most commonly used. And closure 1.9 or 1.10.
I'm just getting compiler exception.
Can you please put it in the chat?
Yeah, I'll PM Ilya.
Compiler exception means, oh, okay, let's sort them one at a time.
Okay, do you see the screen?
Yep.
Yes.
Okay, so it seems like I can't click here at all. I don't know why. And I'm not sure what's the problem.
Is it running?
Okay.
Try to restart, please.
The REPL.
The REPL.
Can you write something now?
Okay, yeah. No, it works.
It's okay. Try to load the file now and see that after you load the file, you can still write.
Okay, so to load the file, I just have to go to Tools and REPL and
choose the file, like click inside, yeah.
Okay. REPL load file.
Yeah. It is a bit nervous about okay, and did you just lose the possibility to write in the?
No,
okay.
So I had just reload it. Okay, and the question was, I didn't get that moment when you had like here, you had a mode chosen. So to understand right, if I'll choose it like here and then
yes, and to the same menu, tools, REPL, and send mol to REPL.
Okay.
But you can write it yourself in the REPL. If you just write mol there, it will be the same.
Okay.
Yeah. It's basically a symbol. It should be there.
Okay, and to return it? Or
no, nothing. Just enter. Yeah, return. Oh, oops. Then maybe with the namespace. Okay, then maybe send them all to REPL will be fine.
Okay. Thank you.
That's weird.
It's probably because his namespace has a slash of the data. Okay. Was there still the question about the couldn't find or load something?
No, I fixed it. Thank
okay. You. How did you fix it, just in case?
I added the closure to a project.
Okay. Any other question?
What did you do to get option to load file to closure?
You click inside the file. You kind of this
Yeah, I
whole,
quit.
all this.
Okay, yes, I right click exercise 1, tools, repo, load. Okay, yeah, I've got it now, but I get compiler exception. Maybe I can share the screen.
Sure.
Okay, I'm sharing screen.
Okay, so there's something wrong with your call to let.
Line 11, I believe.
Haven't modified anything. Okay, yes, I've got this one. Let's.
Oh no. So let expect a pairs of statements, name and some definition, and in your code on the first line where it says customers and function customers to mall, keyword customers to mall, it's cool. So because it's a name and some function. On the next line, it's kind of weird because you have a name, which customers, then for some reason customers again and a function. So it expects 2 values and you have 3. Can you see that? That the first call to customers in this line is redundant. It's not needed.
This one?
Yes.
Okay. But even if it's redundant, it shouldn't really do anything, no?
I
Like
didn't understand.
If it's redundant, it shouldn't matter.
Yeah, redundant was the wrong word. It was misplaced. I don't know.
Okay. Okay, thanks. Now I got it.
Karina, can you show your screen?
Yes.
Okay, so it's not add configuration. You already have one configuration. It's where kata.exercise1 is. Go to the kata.exercise1. No, top right corner. Yes, yes, here. And here say edit configurations. No, edit. Yep. And now plus in the top left. Closure REPL local. Yep, and local one, yes. And just name it somehow, like REPL, for example. Okay. And now you can run it on the top right again, yeah? And it appears, the window appears. Okay, looks good. Try to click inside the file and send the file to the REPL, like. Click anywhere inside the file. No, in the file which is open, yeah, just put cursor there, yes. Or yes, or on the name of the file and right click, I guess, should have a, no problem. Probably not. Okay, just go to tools now. Yes, REPL. And load file in REPL. Oh, okay, there you are.
Thank you.
Any more questions?
How can I hate this syntax less?
Once again?
How to stop hating this syntax?
That's a bit of a question. You know, you
will grow to love it.
Yes, you grow to love it. Well, maybe love is a strong word, but you grow to like it.
Love and hate? Okay.
Yeah, in a way. No, it's annoying in the beginning, and you will make, like, it will be a bit painful in the beginning, but you will grow used to it. The best way to start to love it is to format it, actually, to find a way to format the statements so that they make sense. Once you, and it shouldn't be like an official form, like code style or something, just find something for now which works for you. And once you have it, it will be better and better and better. Like the more you will, like in a way, if you get through with the kata, with these exercises, you will get to like it. Well, maybe not to love it like Nikita says, but to like it much, much, much more.
Okay, there's still laboratory step 3 to go through, so.
Yeah, the laboratory tasks are more for, you know, like for solving like problems exactly. This one is exactly to get you to grow into the syntax. Like,
oh, okay.
To grow into the syntax and to grow into the way Clojure deals with collections, because it's, again, it's one of the parts which we think is one of the best ones in Clojure, like at least best ones in the best ones and most accessible ones.
Better than Python? Better than Python?
It depends on your, like, yes, like for me, yes, but again, it's definitely a matter of choice, right? Python is great too, like not going to shit on Python.
Okay. It's not Java, yes.
Yeah. Better than Java, it's an easy one. But when the collections are built inside the language, kind of the language has many instruments to work with that. Clojure has it, and it's actually nice to work with them. So that's this kata.
Okay. Any more questions right now?
Yeah, I have an error now. It says namespace not found. I can share the screen. I can't share the screen while other participants is sharing though.
Yeah, sorry.
Okay, so yeah, I have this error. So basically I run disclosure, then I try to open this customer's mall. And yeah, it's not working, it's giving me this error.
Right. Yeah.
Have you loaded the file first?
Which file with those exercises?
Yeah, so the idea is that, as you can see at the beginning of the file here, we have the definition of our namespace, and then we import other namespaces here. So I guess that might be the problem. Right now you have this file selected, and you can press Alt-Shift-L if you're on
Alt-Shift-L.
Yeah, okay.
Oh.
Now that you have done that, you can select the form as we have already done, this customer form, this call to the function. Yeah, this thing that is selected, and you can press.
Okay, yeah, thanks.
And it works. Yeah, so to reiterate the explanation, the problem was that before we have loaded the file, the REPL did not know anything about the namespace Clojure kata or kata data that defines our mall database. And I guess that's why that was the problem.
Yeah, thanks. I forgot to press those buttons.
No problem.
Yeah, like we tried to make this kata as friendly and as kind of hassle-free as possible, but a bit of, you know, namespaces juggling like is still there to make it presentable. Like we could put everything in one file, but then it would be horrible to look at. So like this is kind of a compromise of what is readable and what is like still usable.
Yeah, and again, the REPL is not required. You can always fall back to simple run as and run the whole file without defining the REPL, without sending anything to REPL. Well,
can I ask one more question?
Sure.
Don't we have to use like this Maven or I don't know, something else, Leningen, or what was it?
Yeah, we have discussed it today, and we decided that for now we will not use Leiningen.
Again, generally, of course, Leiningen works
things.
and is a standard kind of. But in practice right now, we're just focusing on the syntax, yeah, and we're focusing on the standard libraries. We don't want you to be searching for like overcomplicated solution. Everything which we ask can be done with a few commands from the core libraries. And without them, and if you are working within core libraries, you don't need a Leiningen basically.
Okay, so for all homeworks, we can just do all this stuff without Leiningen. That's right?
Yes, yes. If you want, like, if you want to have a look yourself at Leiningen, like, of course, no problem. And the idea and cursive work with Leiningen pretty well. So, like, if you want to experiment there, of course. But generally, you don't need any third-party libraries. Everything that we want in the homeworks, you have in the core libraries. Okay.
Yep.
Mm-hmm.
Anyone else?
I have a question. I can't share my screen. Okay. I can't run my project.
Start with add configuration. Can you run once again? Could you right click on that? And what will happen if you say run kata exercise? Yeah. Okay, so far so good. Yeah, so it generally works. But now you can go to that kata exercise 1. Yeah, just click it. Say edit configurations. No, edit. Yeah, go to plus, left top corner. Yeah. Yep.
Thank you.
Any more questions?
I'm sorry, I have one more question.
Of course.
I can't load file in REPL.
Click inside the file. It's idea is a bit nervous about focus.
Yeah.
Yeah. No, yeah. Well, yeah, minor niggles. So we are basically through with the time, right? I think that we will basically continue the same thing on the next lecture. Like again, we will give you this time to play with these exercises, and we will be here and ready to answer and to help if you have like questions. Again, theoretically, there are solutions and solutions are accessible, but it would be nice for you to do them yourself without solutions. Yeah, try, like, it is painful in the beginning, but you will learn very quickly. It's not that hard. Yeah, like the syntax is a bit annoying at first. It will become much clearer very soon. To answer how many you are supposed to finish, everything before exercise 8 and exercise 9, so first 7 files, are basically very simple. The 8th one is the first one, which actually presents a noticeable challenge. You will have to write a few of your own functions. You will have to think how to manipulate the data. Again, like I'd say that first 7 is a must for you to feel how it works. The 8th and 9th are basically extra.
But from the other point of view, this is not homework. This is practical exercises that we, our idea was to go through them today, most of them today, at least. We ran out of time, and we will continue this next time. And it will be good for you if you will look at these exercises on your own and will try to solve them. But we will go through these exercises one by one next time. This is not homework. You have separate homework. So you don't have to do them.
Yeah, you don't have to do them. You don't have to send them in the orthos. You can, especially number 8 and number 9, if you make them on your own, send them in. It will be cool to look at your solutions. We might kind of take them into account if there are some marking kind of decisions to be taken in the end, but this is not mandatory. Yeah, this is your opportunity to play in a controlled environment and with us helping. It works better when it's not online, when we are running in the classroom and helping with it, but well, again, it's a remote education, so we get what we have, right? So next time you will have this time to work on these exercises, and we will help, and we will make maybe some of them on our own, like publicly, so that you can follow. So yeah, you don't have to send it in. It won't be marked, won't be graded, but you can if you want.
Okay.
Mm-hmm. Okay, if there are no more questions, then I think we're basically kind of done for today. And then see you next time and continue with that.
Okay, thank you, bye.
So I have an extra question about third homework.
Yes.
There is 17th task for flattening function. I need to check if we have a sequence. Is this allowed?
To check if you have a sequence.
Yes.
Yes, this is allowed, I think. Nikita?
SEQ
I think
and question
so.
mark.
Yeah?
Yeah, I think so.
Yeah.
Because otherwise it's basically impossible to get.
I guess. Well, okay.
The point was not to use straightforward solutions, like implement my filter using built-in filter. The point was to create recursive solutions with building new sequences. So if along the way you need to test if something is the sequence, then it's okay.
Yes, and an extra question: could I define my extra functions, which were
Yeah,
part
sure,
of the task?
sure.
Okay. Okay, thank you.
Sure.
Thank you.
Thank you. Yeah, thank you guys, and see you next time.
Thank you. Goodbye.
Bye.
Bye.